Hello class, this is a video tutorial on graphing combined functions part 4. In this video we'll be looking at some examples. Whilst graphing combined functions can be done using a table of values, it is best to use the features of the graph to sketch combined functions. So here's a summary of all the major points or major guidelines that you can use to find the sum, the difference, and the product of two functions. So you can pause the video and give this a go yourself with these two and these two functions. So here we go. For the sum of two functions, I actually like to find where there are zeros first in both functions, because where there are zeros, it will be equal to the point of the other one. I'll show you what I mean here. So in this case, F is the orange and G is the green. So where there are zeros in F, so here's a 0 in F, it will be for the combined functions where G is going to be, because 0 plus 3 is going to be 3. Likewise for here, G is 0. 0 plus -1 is going to be -1. Another one here. 0 plus -1 is also going to be -1. 0 plus 1 is going to be 1. And 0 plus 3 is going to be 3. So using those 2 points, we can already see a graph being formed. Hopefully you can see it as well. Okay. Alright, so now let's find the next ones. So we're finished with the zeros. Let's find where the points are equal to each other. Well, where they are equal, it pretty much means the graphs are intersecting. It's just going to be double the value of that point. So let's find any points of intersection. I see one here. Now, where it intersects, we take that height and we double it. That point is where this is going to be moved. Likewise for this one, this point here, they intersect. Let's find that height. We're going to take it and we're going to double it. Because remember, this one here, let's say it's 1.9. So F is 1.9, G is 1.9. When we add them, we are essentially doubling the two. And we're done with that one. Finish with this, finish with this. And the last one is when one graph is equal to the negative of the other. This one's slightly harder to find. So let's take a look. I can see approximately at this point, it appears to be that when I duplicate it and move it underneath, it looks very close that there is where a point of intersection is going to be. Sorry, not a point of intersection, a x-intercept, because this height looks to be about 0.8 and this height here looks to be about -0.8. When we add the two, they cancel and give us an x-intercept. Also, it appears to be, that's where, see, notice how it appears to be where it's going to, be found. Because this looks like it's going to be a parabola, like so. Something like so. Now, for this point here, I can see that this point, that looks to be about 0.75. If I were to duplicate it, let's quickly test if this works. Duplicate it underneath. There, that's perfect. That is positive, from the looks of it, 0.75. And this one underneath is -0.75. 0.75. So that there is going to be a x-intercept. So at that point, I missed it, this point here. Now, it looks kind of strange because it may feel as if we want to make it become a parabola. However, notice how at this point it's 0, meaning this point here is going to subtract. So it can't possibly be above because it's actually being subtracted underneath. In actual fact, we can find it because this is going to be 8 take away 1. So the end point is actually going to be something. It looks kind of strange. Something like that. It kind of dips down a little bit. Yeah. And actually, now that I think of it, we can find this point here as well, because that's 1 plus 8. It should actually end at that point there. So this graph should actually curve back down like so, which makes sense as well, because this looks to be going downwards, meaning it'll be underneath. It'll be underneath the curve as it continues. So let's just clean this up a little bit. It appears to be something like so. That there in blue is the sum of the two functions. Let's try now do the difference of the two functions. You can pause the video and give this a go yourself. Let's take a look again here. For this one, I like to find where g is 0 first, because that's going to be the easiest point. When g is 0, f take away nothing, it's just going to be f. So let's find all the points of 0 in g. Okay, so when g is the green, so where green is 0, f stays where it is. So those 2 points there are where the difference of the two functions are going to go through. So when g is 0 is done. Now when f is 0, g gets the opposite sign. So when f is 0, g gets the opposite sign. So this is now currently at 3. It will become -3. Likewise here, it is currently, so f is 0 at that point. When f is 0, g is -1. It will become +1. Okay, and lastly here, f is 0 at this point. G at that point will become -3. So our function is already looking to be something like that from the looks of it. Rather interesting. Okay, let's keep going. We're finished with this one. When they are equal, we get points of intersections. Okay, let's find the points where they're equal. Here, so it goes through x-axis here. They're equal here as well, so that's going to be the x-axis. And lastly, when f is equal to -g, we double the value of f. Okay, so we found those earlier here. So from the looks of it at, let's say here, that is of equal height, but negative to f. So f at this point is going to double in length. Likewise, we said at this point here at 0.5. So f is currently at this point. This is the same, that is the same length but negative. So when we add them, or subtract them rather, this is going to double in height. And that there, I think, already is enough for us to sketch this function. It looks to be the case to be something like that. Now, what it will be here, because now take a look, it's negative minus more negative. So it's actually going to go downwards like so. This one here, it's positive minus a bigger negative. So it's actually going to be going more rapidly downwards like so. It should slow down as we so that there is the function f of x minus g of x. Okay, one last one. The product of the two functions. Okay, so for this one, it's a lot easier. Let's find all the zeros first. So zeros on f and g. So it'll be 0 here, 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 and here. All right. Let's find when f is 1. F is 1, whoops. F is 1 at these points. So when f is 1, the function of g stays where it is. So it's going to stay here, and it's going to stay here, well, here. When g is 1, f stays where it is. So when g is 1, f stays there. G is 1 here, f is going to stay, that's a little bit tricky to see, at that point. Let's take a look at points where it's negative 1. So negative 1 is here. When f is negative 1, well, this should change signs, but it's 0, so negative 1 times 0 stays where it is. Oops. Oops, where's that line? There we are. When g is negative 1, f is 0, so it can't change signs, it stays where it is. And the last one is here. When f is negative 1, this here should change signs. So instead of positive 8, it'll be going down all the way to negative 8. Hopefully you can see the function already being drawn. So I can see it being something like this. Oh. Should go back up and go back down, something like that. We're not quite done yet, but hopefully you can see it being formed. Now, last one. When they have equal signs, they should be on the same side of the x-axis. So from this point to the left, f and g are both positive, so the product should be above. So it should be something like, oops, something like that. Now, in case you're wondering, how do you know whether this should be below or above the actual function of g? Well, since this is 1, okay, that means it's going to be fractions. So let's say this point here, an easier point, this point here, that point is half. So if this point was half times 4 point something, it should become 2 point, half times 4 point, 2 point something. So actually it should be a little bit higher, in fact, like so. So it should be something like that. So because these are fractions multiplied by whole numbers, it should be below the actual curve itself. Likewise with this, these are fractions, but they're negative now. So negative times, let me get a highlighter, negative values times positive values should be negative. So it should be below the x-axis like so. Likewise for these points here, they're both negative. So two negatives multiplied become positive. So it should curve that way. Likewise with this is positive, this is negative. One positive, one negative, they become negative values. So it should be something like that. And also I just realized I sketched this wrong because this is 1. So these are all fractions. These are all fractional values in y. So let's say this point here is negative 0.8 times negative 0.8. 2 decimals multiplied cannot exceed 1. So initially I drew it like this. That's impossible because these are all fractional values. So you can't even exceed 1. So it should actually be a lot smaller than that. So it should be something like that even. And lastly, similar with these should curve back downwards. And now since these are negative, should all go negative like so. So that there are the sum, difference, and product of the two combined functions. Hope to see you in the next video where we go over one more example with this. Hope to see you in the next video. Best of luck.